everybody from Berlin. I'm actually in the Kinvoke offices here in Berlin, just up the street from the convention center and meetup. So glad to be the last person in between you and either going to the pub or going to sleep or what have you for the rest of your evening plans. So let's see, I'm going to present my slides and talk about a pretty cool, exciting open source project that I'm helping out with a bit. So I'm going to talk about Rook. Rook is a pretty exciting, I think one of the most exciting open source projects out there in the storage area. It's very young. It's only about 5 months old and has been created by a company called Quantum up in Seattle. So I recently joined Quantum as an entrepreneur in residence. I'm helping them with Rook and doing some community development, product development. The team is growing, hiring like crazy. It's an open source project. Folks from lots of different companies are starting to contribute. And this is the project I'm going to be talking about today. Just as a quick about me, I've been primarily involved very heavily in the Kubernetes project for about the very beginning of the project, about 3 years ago, and started the community conference, co-founded a company called Kismatic, which was the sort of the first Kubernetes company, focusing on providing services, support, training, development, and tools around Kubernetes. We were acquired by Prenda, which is a platform as a service company in New York, about 9 months ago, and have had a blast working there. And now kind of moving into the next area and some exciting projects. So Rook is a distributed data layer for, you can think of it for cloud native or microservice-oriented applications. It provides native block, object, and file storage for any type of distributed application you might be running on something like Kubernetes, or in the future, Mesos, Cloud Foundry, Swarm, or even standalone. So I'll quickly run through, since I don't have too much time, the history behind Rook and its development, just give you a brief introduction on some of the main parts there, and then talk about how it's actually implemented for being sort of a first-class kind of native system in Kubernetes. And we actually accomplished that through building operators, which is a pattern that CoreOS popularized fairly recently. And then talk through how that actually works. And at the end, I'm happy to take some Q&A from folks, but feel free to interrupt me if you have anything as I go through this. So what is Rook? Rook is battle tested. It's actually built on top of Ceph. If you're not familiar with Ceph, it's probably one of the most proven production grade distributed block object storage systems out there. It's actually the only unified open source layer that provides all three storage types of block stores, object pools, and file system type storage. And it's actually something that is probably running at this point exabytes and exabytes of data in production at some of the biggest companies in the world, and has quite a large community behind it. Very beginning, it's multi-core aware, it has some really great primitives, and it is actually pretty compelling from that standpoint. So Rook is actually built on top of that. Rook does not implement any new data path operations or doesn't aim to reinvent the wheel there, completely relies on Ceph. In terms of being cloud native, Rook is obviously built for this container native world, and it runs Ceph and all of the Ceph components as containers. The Ceph implementation is actually an embedded version of Ceph in Rook. What that means is the team at Quantum took the upstream Ceph code base and optimized it for running on embedded systems, on modern next generation sort of CPU architectures, as well as being very amenable to running in containers as far as all the Ceph components and agents and so on. So we're going to get into some of those details. And obviously the project is open source. It's 100% community oriented. It's up on GitHub. So if you'd like to check out the repo, it's just Rook on GitHub. We talked a little bit about the fact that Rook is file, object, and block storage, and you can actually have native access to those primitives directly. It's also S3 and Swift compatible. The file system is fully POSIX compliant. In terms of actually running on a cluster, it leverages local storage. So if you're running on EC2, you can take advantage of local volume access and storage and resources without needing to go to EBS volumes or external volume providers to serve storage for your applications. Zero touch in terms of what Rook provides really means that you don't have to think about managing Ceph. It's fully managed and lifecycle controlled for you, and you don't need to think about all of the sort of care and feeding, scaling, replicating, troubleshooting, and debugging Ceph itself. When you need to scale or grow your cluster. The Rook abstractions are meant to be a control plane on top of that, so that you can just rely on storage that's actually easy to use, easy to consume, and just works. So Rook is a fairly new project. Like I was mentioning, it was just open sourced in November. It was in development for a few months prior to that, so it's a very, very young and new project. It's already got something like I think 1,500 plus stars, or 1,150 plus stars now on GitHub. I think we're growing by 10 or 20 stars a day, which is pretty cool. So the community is really active. There's tens of thousands of daily container pulls. So maybe a few crawlers or a lot of pulls every day, but I think there's certainly many thousands of new users a day looking at this the system and playing with it and using it. Since Rook is based on Ceph, obviously we have to work really, really closely with the Ceph community, and all of the changes and patches and so on are actually very closely merged upstream to the Ceph project. And there's a really close collaboration. So from the quantum side, we've actually been in the top 5 of the Ceph contributors over the last couple of releases, which is pretty awesome. And Rook obviously is working really closely with Kubernetes, making the experience for running Rook and obviously Ceph very easy and reliable on Kubernetes, but also in the future gonna focus on porting all the same experience and functionality to other communities like Docker, Mesos, and others. So to kind of get into why Rook was built essentially for Kubernetes. Obviously, we have Kubernetes. It was designed for this sort of ephemeral world where everything is failing, and you have this sort of optimization for failure. Everything is expected to fail. You don't SSH into the machine. You don't have the sort of tight association with your infrastructure and your application. You just sort of abstract all of that complexity and let Kubernetes sort of automate all the pain and management of dealing with infrastructure, and allow your developers and operators to focus more at the application level instead of the sort of lower levels of the stack. And it's very declarative. The challenge is that as you have that sort of declarative ephemeral environment, it's been really hard to effectively run distributed stateful applications on Kubernetes in a reliable way where you actually have a data layer that you can depend on without reaching out to an external system or perhaps depending on a cloud provider persistent layer or service of some kind like GCE persistent disks or AWS EBS volumes and so on. And that's where the operator comes in. Where Rook actually starts to add a lot of value for Kubernetes users is when you're running a private data center and you have physical machines that don't have access to the S3, EBS, EFS kind of APIs, and you actually want that same sort of functionality and that same behavior available in your private cloud or even elsewhere, even on a public cloud. Like I was mentioning, you can use local storage. There's a ton of value there. So what Rook is focused on is building a first-class sort of integration with Kubernetes to this operator pattern, which, as I mentioned, is popularized by CoreOS fairly recently over the last KubeCon, actually, in Seattle. They started to talk extensively about this. What an operator does is actually completely codify all of the sort of complex automation and intelligence that traditionally operators have had to figure out how to script around or build a lot of institutional knowledge in the case of Kubernetes with things like the replication controller of choice or the config map or the sort of how do you inject the appropriate environment variable or conditions for images to actually run or things to be triggered in the right order. There starts to become this sort of high degree of complexity when you want to manage the life cycle of stateful applications on Kubernetes. And so with operators, it's actually been a really exciting opportunity to sort of codify a lot of this And what operators provide are a few different primitives. One of the core pieces of this is something called a TPR, which you're starting to hear a lot more about in the community over the last year in Kubernetes. What that means is it gives you this ability to model and create as a cluster operator in Kubernetes a custom and an application specific object, which basically reflects the type of behavior that you want to run in Kubernetes, but is very specific to that application. And so you create that object, and it's obviously treated as a first-class citizen once you've deployed it in your Kubernetes cluster, and you're able to actually treat that object with all the sort of state reconciliation controls that you would pods or secrets or nodes or anything that has the same type of behavior. So you have this OODA loop, which is observing, analyzing, and acting based on all those changes, and it uses the same type of primitives as well to control those things. Obviously, very important to the type of operator pattern, but it's not the one critical ingredient. There's a couple of other pieces to this. So let's talk about one specific example here. What CoreOS did fairly recently is they built an operator for etcd, and what etcd's operator allows you to do is basically treat an etcd cluster as a single entity. And so you can say, I want to create a cluster. I want to scale up and down the cluster. I want to fill it over, back up and restore. And these are some very powerful primitives and commands that you otherwise wouldn't really be able to do in one fell swoop before operators existed. Before you would have to really figure out, where you want to pin each etcd core member in the cluster, how you're actually able to define the logic where when one dies, it actually recovers and joins that cluster in a consistent and reliable way. And there's a lot of complexity to this, especially when you have something as complex as etcd running as an application essentially on your Kubernetes cluster. And so this is really powerful, and it's something that Rook has actually essentially taken advantage of to really make managing Ceph very easy on Kubernetes. So this is just a quick example of how the Kubernetes operator for etcd actually works. So you're talking through kubectl, and you say, here's my replica, desired replica for my etcd cluster. I want 3. Obviously watches that configuration and that manifest and makes sure that whatever you've declared is always available. What the Rook operator does, it provides something pretty similar in terms of needing to deploy all these distributed components in your cluster reliably. So you have, obviously through Ceph and Rook, object block and file storage, and all those things are natively controlled. So with the Rook operator, what you do is you basically deploy a couple of pretty simple YAML manifests, the operator and the storage cluster for all the components that Rook actually needs to stand up. And this is the sort of life cycle that occurs when you do that. What the operator for Rook handles is starting and managing a deployment of the API to actually talk to Rook, a pod for the Ceph monitor, and then creates a deployment of OSDs, which are the object storage daemons or the agents that control object store in Ceph. And it does quite a few other things that, again, you prior to something like Rook existing would have to go through some really complex gymnastics essentially to get working. This is a high-level view of the Rook architecture. Again, this is sort of invisible to developers or frankly operators. They don't really need to think about how all this happens under the covers, but you essentially have your applications that mount to these volume claims, which we're dynamically generating for you in Rook. And you have access to all of these native primitives in Rook for doing block attachments, file system creation, and storing any type of object-oriented media like MP3 or video or so on through the object store. And then, of course, you have applications that can talk to the API for communicating directly through to Rook client or to Ceph. And so if you're familiar with Ceph, it's a pretty complex storage system. This really simplifies all of that and makes it really, really easy to control and consume. And just a couple of commands, you can have this up and running. It's still fairly early stages at the sort of control plane. So in Kubernetes, there's a couple of dependencies that need to be turned on before Rook can work, and some things need to tune around RBAC and mod probe in the Linux kernel for the kubectl client to have appropriate access to talk to Rook. But this is essentially some really exciting progress that the Rook team's made over the last couple of months, and this is the sort of roadmap that you can expect over the coming months as well, through the operator pattern, as well as some of the TPRs. So there's some additional TPRs that are under development for which storage nodes need to be accessed, describing topologies, controlling which devices and directories are used for storage, and so on. So that's pretty much the high-level presentation that I had. I'm happy to take some questions. I didn't have a live demo prepared. I'm just sort of presenting off the cuff here in Berlin remotely. But if you're interested in the demo on the website, it's actually pretty straightforward and gives you a sense of how easy it is, to actually use Rook in Kubernetes. So what we have here is basically creating a couple of deployments or configurations for the operator, as well as the storage cluster manifests. And that's pretty much as simple as it is to actually get your distributed storage layer running in Kubernetes. Again, taking advantage of local storage.